Now I'd like to do a sample problem and try to describe of what a sample looks like and what it can tell us. I've talked to you earlier about my sweet gum trees. Now I'm talking about my blue spruces. Back in 1988 I planted 16 blue spruces. Well, actually I planted 17 and one died after 1 year. So anyway, I've got 16 now. A couple years ago I measured the height of these trees to the nearest foot. And so what I've got here is each tree is tagged with a number from 1 to 16, and then below each tree I've got its height. The first tree is 13 feet, the second one is 12, and so forth. Okay? Notice that the range of trees, the range of heights of the trees goes from, looks like 9 is the shortest one, 9 feet, and the tallest one is 16 feet. 9 to 16 feet of these 16 trees. Now, I have earlier calculated the mean, and the mean of my 16 trees is 12.3 feet, and the standard deviation is 1.8 feet. I figured that by just using my calculator and calculating the mean and standard deviation. Okay, well, before we get into a sample, I'd like to take a look to see what the distribution of my trees looks like. So I want to create a kind of a dot plot where on the x-axis we're going to have the possible heights ranging from 9 to 16. So let me mark that. 9, 10, 11, 12, 13, 14, 15, 16. And up here on the y-axis, on the vertical axis, we'll just have how many? That is the frequency of each of these. Now, once again, I rounded these to the nearest foot. And please understand, this, even though these are whole numbers, these are discrete values. These are continuous values. It's just that they're rounded. My tree heights are actually, not exactly, for example, 12 feet. This tree number 5 right here must have been something between 11.5 feet and almost 12.5 feet. And I just rounded to that. So continuous data can be accurate, only as accurate as our measuring tools. So here we go. See if I can quickly do this. Okay, right along here I've got a 13-footer. Okay, I'll just put an X there. I've got a 12-footer. I've got a 10-footer. I've got a 9-footer, another 12, and another 12. I've got a 16. I've got a 13. I have a 10. I have a 14. I've got a 12. A lot of 12s, huh? I've got a 13. I've got a 14. I've got a 15, and 2 11s. Okay, there's my distribution. Okay, looks pretty decent in terms of a normal distribution, doesn't it? Starts out low, goes up high, comes back down. Okay. Now, if I were to collect a sample from these 16, what can I expect from this sample? In fact, we're going to do several samples. First question is, how many different possible samples are there? Well, it depends on what size of sample I am. So let's say I'm going to use a sample of size 4. Size is 4. I'm going to pick 4 trees. So how am I going to do that? Well, what I did, I wrote down every number from 1 to 16 on a card here, and I put it in a bowl. And I'm just going to do this the old-fashioned way and just draw a number here from the bowl. So let me hold it up so I can't see it. Let me stir it up and pick one, and the number is number 9. Okay, so first tree, number 9, its height is 10. Okay, so let me record that. I've got a 10. Okay, now, what am I going to do with this? This 9. Do I keep it out? Do I put it back in the bowl? Well, all the statistics that we're doing from here on out requires that we have independent trials. That is, we want to have a random sample, and to get a random sample, every member has to have an equal chance of being chosen. And if I take this 9 and leave it out, then the second time I draw, everyone has a 1 out of 15 chances of being chosen instead of 1 out of 16. And if I take that second one out, the third time I draw for my sample of 4, everyone's got a 1 out of 14 chances. So I'm changing. So I've got to take this and put it back in the bowl. Okay? Back in the bowl. So we'll continue this in a second. But now we can answer our question, how many possible samples are there of size 4 if it's possible that I could get tree 10 or tree number 9 and 9 and 9 and 9 again? I could, since I put it back in there. So let's see. I got a sample size 4. That's 4 trials. 1, 2, 3, 4. How many different trees are available for the first one? Of course, there's 16. Since I put it back in, how many available for this one? We're allowing reuse. So again, it's 16. Again, still there's 16. There's going to be 16 trees available as possible samples. 16 to the 4th power is a pretty big number. 16 raised to the 4th power, my calculator says that is, probably can't read it, but this is equal to 65,536. Who would have guessed? There are that many different possible samples I could come up with. Wow. Now, I'm not going to sit here all day and draw all 65,536. I'll do a couple of them. Okay? And I've already started one. I have tree number 9, and it was of height 10. So let me pick another one here. And let me just draw one here, and I got a 14. 14. Tree 14 has a height of 15, okay? Let me get another one here. Mix these up. And what do I get this time? I got 15. Okay, tree number 15 is how tall? 11. Okay, this is tree, and it's 11 feet tall. One more. And let's pick this one right there. And this one is tree number 12. Okay, tree number 12 is how tall? Looks like it's 13 feet. Okay, so tree number 12 is 13 feet. Okay, what am I going to do with this sample? I'm going to calculate this sample's mean. Add these up, divide by 4. So if my calculator, I can do my have and add. Let me do my calculator. That's 10 plus 15 plus 11 plus 13. That equals 49. Divide that by 4. I get 12.25. That's an average. 12.25. And since I rounded my tree heights to the nearest foot, I'm gonna round these also to the nearest tenth of a foot. So this is going to be 12.3 feet. So the mean of this sample is 12.3. And what do you notice? That just happened to be exactly what the mean is of my trees overall. And I didn't plan it that way. That just happened. Would we expect that to happen every time? No, not at all. But wouldn't we expect to come out pretty close to the mean every time? For example, is it likely that I'm going to get a mean average of 4, a sample of 4, it comes out to be an average of 16 feet? Well, the only way that's going to happen is if I would draw tree number 7 4 times. You get 16, 16, 16, 16. That's going to average 16. That's not going to happen. That's not likely. So would you agree that if I took more samples, I would expect some of them to be shorter and some to be taller, but overall, the average is going to probably come out to be pretty close to my average here. On the next video, I will have taken a lot more samples, and I'll show you the results of all my samples that I've taken.